So our subject today is IoT and energy. Can everyone see it?
Yes.
Great. So subject, how is IoT enabling the renewable energy transformation? And IoT will play an extremely central part in it. And we're going to have six panelists today discussing the subject from different industries. Let me shortly tell you a little bit about the background. I mean, what we will be talking about today is the integration of renewable energy, improving energy efficiency, predictive maintenance, smart grids, monitor and control, energy security, and insights from IoT. And basically, what this will lead to, the discussion today, is hopefully give all the attendees a clearer of the idea what we're talking about. So what's the problem? The problem is basically we have renewable energy coming in, and we have instead of a supply network where we have distributed energy, and we need to integrate this energy. And where's the problem? It's on all levels of the energy system. It's on levels of the utilities, the energy producers, and the consumers. Traditionally, the utilities were the main energy producers. This is going to change, or is already changing on large scale. Nowadays, the utilities, at least here in California, for example, are managing the grid. But we will hear more about this from our audience today. Why do we need that? We need it because we need a reliable energy supply, and we could solve part of it through a smart IoT enabled energy ecosystem. And here are our panelists: Arie Brish, who is currently professor at St. Edward's University and is partner at Levant Energy Group. He has worked in renewable energy and other roles. Then Jonas Bull is assisting utilities in strategic decision-making with his company Toro Strategic. And Tom Fellenz, who's a distributed energy consultant for utilities and former PG&E employee. And then we have William Gathright, the CTO of Talos IoT, which is focused on HVAC, smart management. David Stephen Jacoby, who is the CEO of Boston Strategies International, and Mithun Nagabhairava. I'm sorry if I spelled that wrong. That's really hard. That's even harder than my name. Who works as a senior consultant for Rockwell Automation. And the moderators are me, Volkmar Kunerth, and Gary Kent Ramsey, who's an innovation IoT leader. And this is my contact information for later, Kunerth at accentectechnologies.com. I'm hosting this with the North Texas IoT group. So, and that brings us to our next step in the discussion. We are opening the discussion around here, and I'm asking David what he thinks and why IoT is so important in the current energy environment.
Well, thanks, Volkmar. I would say IoT is important because it's changing both the technological and the commercial landscape of the whole energy industry, and energy broadly speaking. I mean, oil, gas, and power, as power in all segments as well, generation, transmission, distribution. It's really changing there's such an influx and a rapidly changing field of technologies that it's hard to keep track of. Some of them have been around for a long time. For example, energy storage, has been maturing for decades and decades, but there are still some things on the table today that are vastly new and not even and speculative almost, such as solid state batteries. So there's a lot of sort of brewing innovation going on. And then on the commercial front, and fusion energy as well, which IoT fits into as well, and fission and fusion nuclear well. And then on the commercial front, there's all sorts of dynamic change being created by this technology. The relationship between the ISOs and the local distribution companies, the relationship between microgrid, who will be operating the microgrids and who will be maintaining, what will happen to the future of centralized power generation utilities, and then the introduction of a whole bunch of intermediaries into the smart grid scenario, new players entirely, like Enbala and others, come in to manage energy, DERMS, suppliers, distributed energy resource management providers, and hybrid companies like Tesla that fit into the auto space and then into the energy generation space as well, and energy storage. So really this IoT and energy, broadly speaking, is creating a cataclysmic shift, I think, in the whole energy industry. And as you correctly pointed out in your introduction, it's really responsible at the core, at the center of the whole energy transition. I would say that's what we're dealing with.
Okay, thank you for this very good introduction, David. Tom, would you please tell us from your utility and energy background, what differentiates utility energy IoT of the past from now and the present and the future? You're muted. You need to unmute yourself.
Indeed. Thank you. First off, thank you for including me on this panel. Very good to be here. Thank you. And so the primary difference is that there's more granularity of data available, especially in the context of the devices being sensors, being able to understand exactly what is happening at a specific point in the, most important in our realm for new generation is the granularity of data for telemetry, understanding exactly where the energy is being produced, what the power profile is of those devices. In the past, in the utility space, we typically have seen SCADA used for IoT, specifically like motor operated air switches, being able to control devices out in the field. And so at this point, I think we have a larger discussion as to what you'd consider IoT in the renewable space now.
Okay, sounds good. Jonas, you also worked a lot for utilities in the Southwest. What is your take on how utilities need to transform themselves to bring maximum value to in times of the renewable energy revolution, and what does IoT play? What role does IoT play in that?
I'll say thank you again, Volkmar, for putting this together. And most of my experience with utilities is in the Southeast rather than the Southwest. And we've had a great example of what can go wrong just recently with the Hurricane Ida coming in and knocking out power to many places. And from the perspective of utilities, one of the things that utilities struggle with is regulation. There's a ton of regulations, some of which are administrative, some of which are safety, and some of which are some mixture of both. And that's one of the things that around IoT, as we're building out new systems and new regulations are coming online, we need to try to help our legislators and representatives understand what's being asked of them in that regard. More tactically, one of the things that utilities can use IoT to do, just one example is as we build out smart grids and get more intelligence built into the system, we can identify where outages occur more quickly. We can identify where those outages are more accurately, so that our linemen are spending less time searching and more time fixing, and we're able to get people back on the grid and able to use get their power back on much faster and much more efficiently, for example.
That's great. Thank you. Arie, you have been in the past and even now working on the renewable generation part. You were involved in solar companies and so on. Where do you see IoT sensoric happening in those generation and renewable energy generation parts?
Good evening. Thanks for having me and the panel organized. You break the word IoT to two things, so two elements. One is the things we're talking about. These are all the physical elements out in the field. And one is the so-called internet, but I prefer more to look at the I as integration, not just internet. I mean, the connection of all the things, all the devices into some central office is pretty trivial. The problem or the challenge, the real challenge is what do you do with all this data? And the problem or the challenge becomes even more important when you talk about renewable energy. When you have a generator, predictable gas generator, or nuclear generator, or a coal generator, the in and out is pretty predictable. When you start to deal with solar and wind, and here in Texas, wind is very significant proportion of the energy input. All the inputs becoming unpredictable. The wind is changing. Yes, you can predict that tomorrow will be southwest wind of 10 miles per hour, but all the gusts are changing direction and changing speeds. So the importance of these sensors in the field to provide the input is becoming very critical to be able to respond correctly to the changing conditions, whether it's a wind changing direction, changing speed, clouds, putting shadows on the solar panel, everything, all of this. And all of that is coming into a data center that crunch all these conditions and optimize how to allocate the different energy sources and integrate all the energy sources. So this is on the supply side. On the demand side, you have things, again, in your house. Those are the thermostats of your air conditioner, for example. And those are a little bit unpredictable as well, because the forecast could have been 95 degrees, but it happened to be 97. That's a major change of load on the grid. So you have millions of unpredictable inputs that you need to react in real time. And that's where the challenge and the need of IoT comes. In predictable generation, we had devices, sensors monitoring what's going on in the generator and the oil rig 30, 40, 50 years ago, but those were pretty much predictable, and their role was more in the maintenance and to detect if there is a malfunction somewhere. But now with the renewable energy, it's almost a real-time thing, not almost, a real-time thing that you need to adjust every second to optimize.
Thank you. That brings me to my question to Will, actually. And that has to do with basically smart decision making on the edge and smart sensing. What do you have to say about the role of edge computing at the edge and how it influences renewable energy?
Yeah, it's an interesting question, Volkmar. So just a little bit of context. My name is Bill Gathright. I'm the CTO of Talos IoT. And so that means I spend a lot of my time thinking about how to sensor up critical equipment and to make sure that it's sort of working as well as it can all the time, right? So that puts me squarely on the load side, and that puts me squarely in the camp of like having to delight customers all the time, right? So to me, that's the sort of the number one thing, right? Is you have to sort of craft your edge computing solution, and make it a really good fit for the use case that you're trying to do. And from what I've seen out in the marketplace, this tends to fall into sort of two camps, right? So we try to keep our edge devices as sort of thin as possible here, right? We want them to be cheap, we want them to be ubiquitous, and we want them to be like pretty robust, right? And some of those things really start to break down if you try to get too fancy out at the edge. And this has a really interesting side effect, which is we can put these sensors out there and they're put there for some particular use case, right? So that is, let's say, to make sure that your HVAC is working really well all the time, or to make sure that it's not burning more energy than it really needs to. But we've been able to do things such as notify the utility when the power was out at a certain customer's building, in many cases sort of before the utility themselves knew, right? So once you can sort of put this edge compute out there in the field, have it connected, have it working in some kind of rock solid way, there's all these sort of add-on effects that are really, in some cases pretty unexpected and pretty delightful, but you never get those goodies unless you can get that sort of, hard core of customer value to start with.
Thank you. And Mithun, would you please elaborate on you're working for one of the biggest automation providers, Rockwell, in the world. You have done tons of large-scale IoT projects. Would you elaborate on the role of those automation companies as it relates to integration of different energy sources and what you have done there.
Absolutely, great question. Pleasure talking to everyone today. As Volkmar said, I work for Kalypso, which is a Rockwell automation company, and we partner with industrial manufacturers around the world to all the way from IoT digital projects to energy management and optimization projects, right? So one of the key things that we have been seeing in the market space is with the trends with Industry 4.0, there is a big trend towards the convergence of OT and IT. And what I mean by that is, traditionally the control systems the Rockwell automation provides have really automated various aspects of manufacturing operations, manufacturing production. Now, the interesting things that with the convergence of IT and OT, how we're helping our industrial clients is really, with the help of digital platforms, we call it industrial Internet of Things platforms, which are what we do is we basically bringing the real-time energy usage from various different parts of the manufacturing plant, right? Like understanding the real-time trends, analyzing what's happening within the plant, and put that in the context of production operations, right? Manufacturing operations. So, putting energy in the context of, the production process, the operations, and also, linking the information with the IT systems, like, the manufacturing execution systems, ERP systems and utility systems and weather systems as well, right? So what we have been seeing is two things. One is when we are putting things into the context of manufacturing operations, energy is becoming mainstream to everything else that's getting measured within the performance of operations. And two is by looking for really interesting high opportunities, companies were really able to identify double-digit improvement opportunities to their bottom line performance, right? And so that's one piece of it. The really interesting and the cutting edge piece of what's happening right now is, as Arie has mentioned, there's an abundance of data. Especially in manufacturing industries, there is an abundance of asset data, energy data, and whatnot. Now, the really cool thing that's happening right now is companies are transitioning from energy management to energy optimization, which means leveraging the power of artificial and machine learning algorithms to understand the future energy usage while not compromising the product quality. And marrying the based on what the prediction equations and what you're able to predict, the really powerful thing that we've been identifying in automation companies is you're actually able to bring the prescriptions back to the control layer and change things within the manufacturing floor to reflect the energy usage, right? So overall, I would say by summarizing by saying energy optimization capabilities in IoT platforms has been a game changer for many companies, but the really cutting edge functionality is marrying the data science capabilities with the industrial automation capabilities to close the loop and optimize energy usage within manufacturing plants.
Okay, thank you. So what we're hearing now is the different levels. On the one hand, we have how energy can be saved and managed on the level of factories. Then we have the utility level, and then we have the integration of renewable energy. So David, would you kind of elaborate on how IoT will help scale that the system of I call it now prosumers and DERs, and how the new energy future will look like? We are in the beginning now, and could you just tell us a little bit about your experience of distributed energy resources?
Well, I think you've hit on a very exciting question, and this is actually the kind of center of the vortex of the heart of the question, if you will. So I think you were looking at the transition from a centrally run electric grid, essentially, to microgrids and energy islands and storage solutions that operate independently. And so what's in a very broad sense happening is a little bit, you could call it the democratization of energy usage. In a centralized world, the utilities, since about, I think, 1930, especially regulated utilities, have had a pretty stable life and a business model. And now you have a lot of disruption occurring, some of which is not even clear today where it's going to go. One example would be the use of electric lithium-ion batteries in electric vehicles, which will then plug into the grid when they park at home or at the office or wherever, at the store, and then convert or charge the system or download from the system, one or the other. And then you also have microgrids occurring more and more at the home. And at the same time, so these are disrupting the centrally run structure that has existed for so long. I don't know if this is getting at where you were headed, but some of these changes have yet to be seen. And when you look at everybody's forecasts, you look at IRENA's forecast and NREL's forecast and DNV's forecast. Everybody has their hockey stick projection out there about where things are going to go, and really there is some uncertainty now about the penetration rate, future penetration rate of EVs, and then once they do exist, how much are they going to plug in, and at what times are they going to plug into the grid? And companies like Fluence are in the middle of this, with Tesla's in the middle of this. They're actually kind of serving this microgrid market and going after it with products like the Powerwall, which then become, you mentioned prosumers, become able to actually supply power as well as download power. So the as the system moves to more of a decentralized control, it sort of raises the question a lot: what is the future of those centrally run power grids, especially if there's energy storage and there's no need or less needs for peak power from those large plants. So there's a really good analysis of this out there. If you want to read a good book on it, it's called Power After Carbon. This is, and it does a deep dive into the restructuring of the whole energy sector and what are the alternative business models for these big power generation plants and companies. And another dimension I'll mention is, I think, is kind of interesting about all this, is that in the United States, we have a very large area to cover, and even within ISOs, each ISO, I think there are 9 of them, and it's pretty large areas to cover. Whereas in other countries that are smaller, they can democratize quicker because there's not as much sort of soft and hard infrastructure to transition as you move from a centrally run to a decentrally run distributed energy system. And so there's a kind of a race going on, I would say, in terms of which countries can actually make this transition to clean energy quicker than which other countries, in light of their regulatory frameworks, their inertia, their levels of innovation, and their levels of deployment.
Thanks, David. You brought up a lot of points. Definitely, but that kind of brings me next to our utility guys in the room here. So Tom and David brought up a lot of points: integration of electric mobility, DERs, peak. This is all challenging for the utilities. Can you tell us how the utilities, and specifically PG&E, is preparing for all of this and how they are utilizing the Internet of Things to make this vision or true what David just spoke about.
Well, thank you. I will have to honestly say that large of a vision, I will have to defer to the powers that be at PG&E, because when you involve so many different layers of planning, all the way from your general rate case to down to the programs that I was part of in the EPIC program, the electric program investment charge, which was a place to receive funds to do development, proof of concept, help with startups doing incubation. That was really where my feet hit the pavement, where understanding what new technology can actually be brought into the utility. I will have to say thank you for the opportunity to talk about the big picture, but let's, for me, I'll be covering, one of the key pieces that PG&E is focusing on is actually deploying new technology specifically to address DER. And one of those is the IEEE 2030.5 spec. And with that, it just allows you to have a more specific profile data capture from energy generation, storage, variety of different energy sources that are within a remote grid. And with that, you essentially are changing your ability to recognize, control these devices, and with that, also bring all of that infrastructure or the new generation into the marketplace. So how that affects the systems internally, PG&E is in the middle of major investment, refining, developing their new systems. And at this point, we can talk a little bit more about 2030.5, perhaps in a more deep dive at a later time.
Thank you. And Jonas, what do you think about the question of how to prepare, or how utilities are preparing with the help of IoT? I mean, I followed the whole thing, and the deployment of smart meters is now going on since about 10 years. Here in Silicon Valley, for example. I mean, that's one thing, but what other things do you see on the horizon that utilities are doing to be prepared for the new energy future? Because it's coming very fast. I mean, by 2030, countries want to have already 50 to 200% renew electric energy fleets. I don't know how that will happen. We would need like millions and millions of charging stations going to the grid, and yeah, maybe you could elaborate on that.
Yeah, no, that's a concern for sure. I mean, we've mentioned several things. Several things have been mentioned that that lead into that. David mentioned prosumers, which and talking about local energy storage at the at the individual level, individual home level. We also have that capability at the building level and the community level, and the ability with 2030 is considered to be the protocol for DERs, and the flip side of that, or the other half of that, as I believe Arie mentioned earlier, is not only managing the local storage and local generation, for prosumers, but also managing demand. So as as these things come online, more charging stations and so on. And let's be honest, energy consumption has just gone up and up and up for years now, and it's not gonna, electrical is not gonna stop anytime soon. So having ways to buffer demand at the local level and buffer demand, especially as we start switching to renewables like wind and solar, where demand is, or rather generation is very dependent on conditions that we have no control over. That ability to manage not only the supply but also the demand, at a very fine-grained level, is going to become more and more critical. And so the companies, the utilities that are, and some of the ones that I've worked with have been kind of leading the way on that. And you mentioned smart meters, and some of the ones I worked with have been doing smart meters for quite a while, and rolling that out fairly early. And so that ability, the ones that jump on that kind of thing early are going to see benefits in not only in terms of their general bill rate and things like that, but also in terms of better operational efficiencies and better customer satisfaction scores, which as things become more democratized is going to be a bigger and bigger issue. But I think the main thing that utilities especially need to think about is that what got us here is not going to get us there. The way we've done it in the past was great, and it worked really, really well for a long, long time. But as things are changing and the direction of where demand is headed, as well as where generation is headed, what got us here is not going to get us there.
Yeah, so I looked a lot into it, and actually there are companies that provide virtual power plant structures now that help intelligently manage the grid. And who wants to speak to virtual power plants and how they integrate into current grid infrastructure? Maybe you will.
Yeah, we've done some work in this area. So right now, actually, the short answer is that it's not nearly as sort of like decentralized as somebody like me, who's like a big computer nerd, would want to see, right? So the process for getting a system online in some kind of a virtual power, maybe I should take a step back. So just a little bit of context for the audience, right? A virtual power plant is this notion of, if you have distributed generation or distributed energy storage, each individual unit might not be that impressive. It might be 1 kW, it might be 5 kW, it might be 100 kW, but sort of by all their powers combined, you start to control real power, and you do it in a way that's very like interesting and very strong for the grid, because it's not all stuck at the end of a long wire somewhere, right? The power is placed where it's the most valuable, which is close to the load. So you get this very nice fine-grained control over where the benefits arrive, right? But this is a big sort of data and orchestration problem here that I would just, if I'm being very blunt, the current infrastructure is not set up to handle that well, right? We've controlled either loads or battery storage systems that are in buildings with ailing power transformers or other T&D equipment right outside. And it's one of these situations where we could have done a lot of good for even that particular piece of equipment, right? We could have taken some load off of it when it was crucial, but there was nothing in place to get the signal when it was time to do that. There was nothing, and then there was also no way for the storage owner to sort of share in some of those benefits, right? So I believe that this is this is the future. Like if the grid, the grid in this country needs trillions and trillions of dollars of work, it would be a real shame for that to all happen from the top down. I think that would be a big opportunity lost. And so if we're going to mobilize some of these like decentralized assets, it's really a data and a coordination problem more than like a raw technology problem.
Okay, you bring up an interesting point. That brings me to Arie. What do you think needs to be done in security for IoT and energy and in the infrastructure? I mean, we see that a lot of the fires here in California are caused by the grid, basically, and that's not, I mean, you could remedy it with IoT to a degree where you would be much faster recognizing what's happening on the physical ground, but actually it has to do with probably too many power lines not being equipped for the load that goes through, or power lines too near to the tree lines and so on. I just read recently that the CEO of PG&E suggested to put all power lines underground now, which would be probably very expensive, but considering the costs and lives it costs, it did cost. So Arie, could you speak to that security, cyber security, and of IoT and security aspects as such?
Okay, there are several dimensions to the security and cyber security of IoT. The major source of the risk here is the fact that all these assets are sitting somewhere out in the field, maybe with a little fence around it, but not much more than that. There is no security guard or anything like that. So you can walk in, cut the fence, connect some device into the IoT device and inject some bad stuff into the grid. And from there, you can go in two directions. One direction is the risk to the grid itself. You can shut down the entire electricity to a whole big city or a whole state or a whole country. You can open the floodgates of a major dam and drown a whole city downstream. So all these damages can be done virtually if you just connect the right device to an IoT elements somewhere in the middle of nowhere that nobody even watches. So there is a whole field of cybersecurity that address that risk. The good news is cybersecurity for OT, operational technology, that's what they call this network, is a little easier than cybersecurity for your computer at home or the office, because the traffic on the grid, on the control of the grid, is more predictable. They send a packet of status report every so many minutes, on the dot. So if there is any deviation from that, that's a red flag for the security system. The other risk, if companies are not careful, the operational network can leak into the IT infrastructure of a company. And we saw that in 2013, when Target were hacked and thousands of credit cards were stolen. The entry point for the hackers was the network between the HVACs in the system. So somebody did not pay attention and created a leakage path between the control of the HVACs on the roof of the Target stores and into the credit card databases. So that's a big no-no, allow something like this to happen. There is another example, maybe not from the energy, but a few years ago, the government did an experiment and penetrated the aircraft control, commercial aircraft controls or flying system by connecting a device to the entertainment system of the airplane. So one way to, like in physical security, you create compartments that is difficult to pass from one another. The same thing needs to happen in the cyber, in the internet, in the network.
Thank you.
So, yeah.
Oh, yeah. Didn't want to interrupt you.
No, that's, go ahead.
So, Mithun, would you please tell us a little bit from the, let's say, industrial customer side where Rockwell Automation is very strong? Is there a tendency, I mean, I know from Germany, a couple of companies, they become completely energy independent, basically while still being on the grid, but they produce their own energy on site and then feed into the grid. Is there, do you see projects there where companies just say, hey, I don't trust that new renewable, that new energy future, and I don't trust that the utilities will be able to do that in the future?
I mean, great question. So, and I'll just, speak to kind of my experience talking to clients, day in and day out in this space. The first, approach that every, many of the major, customers are taking is how do they get their energy footprint less, right? Like, there is always a, like, for all these companies who have net zero carbon targets by 2025, 2030, or what have you. Many of the major companies are always starting with reducing their energy footprint in their manufacturing operations, in their supply chain operations, right? Now, once that's coming to a level where they're showing improvements with respect to a particular baseline, there has been increased renewable energy installations on site, right? Within the manufacturing operations. So now are they full-fledged to support the entire needs of the plant? Probably not. But have we seen clients who have been creative to augment the power from renewable energy usage to reduce their peak demands, in a combination of batteries and using renewable energy for key areas of key energy usages? We have seen that happen, right? And also typically, if you speak to heavy industry processes like mining metals, like steel industry, or even large vegetable oil manufacturers for consumers, right? They typically have this cogeneration system. So what we've been seeing is in these specific niche industry, I wouldn't say niche industries, but heavy process industries, where they have cogeneration with steam boilers, turbines, generators, right? And then also have some footprint of renewable energy usage. Increasingly, clients are rather than question the utility, like our utility is going to get us there or whatnot, they're following their own goals that they have set, like as a company. So in terms of priorities, always looking at reducing their current energy footprint, and then integrating renewable energy, also augmenting it with cogeneration. So the questions become, what are the right strategies? When do I need to use what? How does it help reduce costs? How does it help reduce peak demands? Not only now, for the future, and how does it overall help me with the net zero carbon reduction goals that many of these companies have? So I've not seen very many debates with utilities, but more so in terms of creativity on how they can improve themselves.
Okay. David, you have just written a book, and it happens to be, it is officially coming out today or yesterday. So two questions to you. Maybe you want to talk a little bit about your book, but also, and you mentioned one book before, what books you recommend for our audience to read on this subject?
Well, sure, Volkmar. Thanks for the introduction on that. The book that is came out today, it's available everywhere now, is called Reinventing the Energy Value Chain. And what it does is it lays out 80 to 90 roadmaps for where energy supply chains are going into the future, and where the big axes of opportunity and challenge are in 10 different major energy technologies. We also split oil and gas into upstream, midstream, and downstream. So it's 12 energy technologies in total. And this also kind of looks at the whole transition from a supply chain value point of view, which in my history of 33 years of consulting in supply chain management means basically how do you generate shareholder value using supply chain levers. So it's not your typical just logistics optimization. And so we present some really new and interesting, I would say groundbreaking analysis in there that shows the basically the supply chain advantage of renewables in being able to generate increasing sales and increasing demand of electricity and power generation. So that's a kind of an interesting one, and it's published by Penwell, as was my previous book on oil, gas, and power generation. So Penwell's is very respected in this sector, as you know. The other books which I might have mentioned were Power After Carbon, I thought was good. That's published by Peter Fox Penner, who is the director of Boston University's Institute for Sustainable Advantage, where I'm a senior fellow. And the book is 5 stars. I mean, no matter how you cut it. There are also a couple organizations out there that produce good material that goes into a lot of depth on these trends that are pretty reliable. Some are more biased than others. A lot of people criticize one or two of the agencies, I guess I shouldn't say which ones, for being biased in their projections. But I do think the projections often coming from the laboratories in the United States are pretty good and pretty on target. And we're working with them actually at Boston Strategies. And one of the things, laying out these roadmaps for our clients so that they can follow the right path and do it in a timely way to maintain leadership in the industry rather than getting sort of overtaken. So if I could just take another minute, and while I still have the microphone, and basically go back to what Mithun was saying, which was really, I found right on target. The heavy industrial producers have often managed their electricity separately from really independently, more or less, from the grid operator and power generator. But this is increasing now dramatically as you look at companies like ArcelorMittal and others who are responsible. Now they produce something like cement or steel or petrochemicals, and there's no way that they're going to become carbon neutral without some dramatic change. So they can't just say, we're going to reduce the power we draw off of the utility, because they know that will not get them to carbon neutrality. They have to look at something sort of a dramatic technological shift of somehow, how do I make carbon-free cement, etc., steel. So now this is increasing the independence of these heavy industrials from the traditional grid, I would say.
Okay, yeah, that's great. Thank you. So I had a couple of questions from the audience here. One was, what is the potential cost savings that a client could have with IoT? Will, I think you would be well prepared to speak to this in regards to your company, who is specialized utilizing IoT, saving energy saving, maintenance, and so on.
Sure, absolutely. So the savings can actually be pretty dramatic depending on who you are and what your use case is. So I'll give you two really quick examples, right? There's the most pedestrian use case you can imagine, which is this is something that we can deliver on for probably 75+% of our clients, which is almost no building is configured correctly. There's almost no building automation system that's configured correctly. Many HVAC systems will run all night when there's nobody in the building. You know, this is not like a Zen riddle, right? If there's an HVAC around and no one's around to enjoy the cold air, yeah, it still costs you a ton of money, right? So it sounds really stupid. It's a very real and a very dollars and cents use case for IoT, just to tell you that your thing is on when it's, you know, when it shouldn't be on, right? And to do that every single day without fail, so that even if you make some changes, those changes stay. So that is permanent energy savings. That is permanent, like, megawatts right there, right? And when you start to see things like that, you know, a little IoT device on a big 80 or 100-ton HVAC starts to pay for itself pretty quickly, right? Sometimes even within weeks. And then there's the more dramatic use cases, such as for like truly mission critical equipment. Let's say, you know, we have some industrial customers for whom downtime is just, you know, completely unthinkable, right? Downtime costs millions of dollars a day, right? These folks really, really, really need to know, not when their system is dead, they need to know before their system is dead, right? And even there, the energy, the dollar savings can be dramatic, right? If the guy shows up with the right part at the right place, they can schedule maintenance instead of having emergency downtime, you know, again, to the tune of you know, $5-6 million a day. You know, that makes a big difference, right? That's a very compelling use case and a really compelling business case.
Okay. Yeah, so who wants to speak to the subject of systems, infrastructure, platforms, and scale of implementation, and specifically hyperscaler web services?
I mean, I can touch upon from a manufacturing industry's perspective, right? The in terms of integrating with, you know, one of the great things industrial automation companies have done is they've automated a lot of different processes, which means there's no, you know, manual interventions and deviations within the process. But having done so, there are quite a few communication protocols, both in IT systems and OT systems. Now, there are, you know, I don't want to specifically point out, you know, a particular, you know, tool or whatnot, but there are, you know, tools, for example, as Kepware, that has the connectivity to talk to an array of operational devices, OT devices, you know, be it smart sensors, be it PLCs, be it, you know, other different, you know, variable frequency drives, etc., from an operational floor perspective. And, you know, we're speaking about the subject of IoT, and with industrial Internet of Things platforms in the manufacturing space, many of those come with, you know, connectivity protocols to a variety of, you know, software systems, IT systems that a plant would typically have, be it MES, be it ERP, be it, you know, or what have you, right? So, or even connecting with different databases that are homegrown within a manufacturing plant. So a variety of, you know, connectivity tools, a combination of ones that could extract data from the operational systems, and the power of the IoT tools that are bringing in the market space that can talk to all these IT systems would really unlock the value of bringing the right contextual data in a client setting.
Okay. I have another question here from the audience. What do you see the role of IoT with centralized renewable energy, such as geothermal or hydroelectric? David?
Predictive maintenance.
Okay.
That's the answer. I mean, the IoT, AI, all that kind of stuff. In a grid application and distributed applications, there's tons of nuances. There are 12 different ways you can stack a business case for energy storage. There's all sorts of complexity in geothermal, and what was the other technology? Is
hydroelectric.
Hydro. Yeah, well, hydro, you're talking about, the big issues, the big opportunities for hydro are green hydrogen production with either hydrogen or geothermal, because they produce a very steady rate of production that's very reliable and it's very high volume where it is naturally located. But for IoT and AI, the main business cases and use cases fall traditionally in the turbine vibration sensing and other sensing, so that you can actually optimize when you're going to put that thing up for heavy maintenance. And that can, heavy maintenance on those kind of plants costs, almost half the cost of just rebuilding the whole plant. It's a very heavy thing. So predictive maintenance is really important. And that is the traditional, or the new impactful application of, I would say, AI and related IoT.
Okay. Thank you, David. So there was another question here. If there are laws in place that require the development of green energy buildings and mainly solar. I think there are here in California, there are laws. Maybe Tom, you want to speak to that a little bit, or? So as far as I know, in California, every new house that's in building it's going to be built, and that is, I think, from January 1st this year, has to have solar installed. So some of it's regulated by the states, and some of the states are very aggressive about that, and some are less aggressive. Some have, like Texas, very strong wind energy, large-scale projects. So answering to that. What are the less environmental impact options available besides the traditional ones? I don't really understand for what particularly is meant here. Maybe someone could answer that. Okay. Yes, Arie.
I'm not sure if that's what the question was intended to, but there is no such thing as creating or generating energy with no environmental impact. The trick is to create the right mix so you don't kill a whole ecosystem environmentally. And like any technology you can think about create some environmental impact, whether it's wind turbines, visually killing birds, solar panels on a large scale, putting shadows on the desert, and interfering with the ecosystem of different snakes and lizards and what have you. If it's a hydro planet, think about the lake it creates. It covers with water a whole ecosystem on one side. Think about all the pollution impact of creating or manufacturing all the concrete you need to build this large dam. So any clean energy has some environmental impact. If you do too much of any one thing, you create, the impact is too destructive. If you find the balance between the different technologies, the impact will not be that destructive. I'm not sure if I answered the question.
Yeah, I think that's a good idea. I mean, I think low impact, and while you were talking, some things came to my mind and that's been done for thousands of years in Mediterranean countries, to paint your houses white. Yeah, that's has a very low impact, very low environmental impact, because you have to paint them anyway. but it makes a big difference for if your roofs are white and it's a very low, let's see, very low hanging fruit. Or in some cities I saw in India paving the streets white also. Very low impact with a lot of result.
Living in the Middle East for many years, we used to have a flat roof in one of our houses. You paint it white in the summer, you paint it black in the winter. You also build the houses with very high ceilings, so in the summer the hot air goes up, the layer of hot air close to the ceiling, but down where the people are, it's much cooler.
Yeah. Thank you. Another very interesting. It's not IoT, but it's a question that came up. So, are there any? We are already a little bit past 5, but that was okay. I thought the session is until 5. So, do we have any more questions? If so, please text me here in the chat. Okay, I think I guess that's it for today, and I'm extremely thankful for all the speakers today, for their expertise, their time, and I will follow up with a email to all the people who participated or who couldn't with the video link, and in that way, and the presentation, and in that way they could connect to the speakers if they want to have more. And we had 500 people signed up for the event. I think we had about 100 today here live. And also want to thank very, very much the North Texas IoT group for co-hosting this and for being with us. It's always great to work with you, and wishing you a wonderful upcoming weekend, Labor Day weekend, and I hope to stay in contact. And thank you so much for all the speakers and their input.